This Zoom session has been brought to you by the Fractals Inverse Bullseye Swirl and Heart of Gold. Today we do some factoring, and as I mentioned before, we factor in order to solve equations, which we'll get to in a few sections. So here we're going to factor a quadratic, ax squared plus bx plus c. Before we had a was equal to 1, and we had this rule where p plus q equals b and p times q equals c. Here's something called the AC method, which is similar, where you factor this by finding p and q whose sum is b as before, and p times q is now a times c rather than just c. Once you find two such numbers, p and q, basically by searching amongst the factors of AC for ones which sum up to b, then you write ax squared plus bx plus c. You write it by rewriting this term bx as px plus qx. Then these four terms will factor by grouping. For example, 2x squared plus 5x plus 3. You find two numbers which add 5 and multiply to 2 times 3, which is 6. Well, 2 and 3 work. 2 plus 3 is 5, and 2 times 3 is 2 times 3. Works fine. So we write 5x as 2x plus 3x. So you get 2x squared plus 2x plus 3x plus 3. These two terms have a common factor, namely 2x times an x plus 1. These two terms have a common factor, namely 3, also times an x plus 1. So you pull out x plus 1, and that times 2x plus 3, and that factors this. So, okay, we'll have several of those. Let's proceed. Now, here's the book doesn't actually go into why the method works. I think it's worth mentioning. So here we go. If p plus q equals b and p times q equals a times c, then q is ac over p. Just transpose the p. Then ax squared plus bx plus c, we write bx as px plus qx. Ax squared plus bx plus qx plus c. This qx we write as ac over px. Then we write c as cp over p. That way we have a factor of c over p in common here. Ax plus px is a factor of x, out comes a times ax plus p. AC over px plus cp over p, remove a factor of c over p. We're left with ax plus p. And now here's a common factor of ax plus p times x plus c over p. And we're done. That's all. So that's why. So the AC method will always work if you do it right. So we'll do some examples thereof. All right, there's a bunch of examples. And as ever, when we search among the factors of AC, we go through a system. So, okay, 8x squared minus 22x plus 5. P and Q have to sum to negative 22. Their product is 8 times 5, which is 40. So 1 and 40, 41. Wrong sign, wrong size. Negative 1 and negative 40, negative 41. Right sign, still wrong size. Then try negative 2. 40 over negative 2 is negative 20. The sum is negative 22 as befits. So here we go. We write minus 22x is minus 20x minus 2x. 8x squared minus 20x minus 2x plus 5. All right, 8x squared and 20x have a common factor of 4x times, when you divide it out, 2x minus 5 minus 2x plus 5. Now, we want to have it, this is a minus 2x plus 5, and that's wrong signs. So we'll pull it a negative 1, and that's times 2x minus 5 times 2x minus 5, 4x. Remove a common factor of 2x minus 5, and we are left with 4x minus 1. Here's 15x squared, t squared, minus 26t plus 7. All right. The p and q have to sum to negative 26. Their product has to be 15 times 7, which is 105. And again, we try various factors. 105, sum is 106, wrong sign. Negative 1, negative 5, negative 106, right sign, wrong size. Try negative 3, negative 35, negative 38, not yet. Negative 5, negative 21, and negative 26, it works. So we rewrite as minus 26t is minus 5t minus 21t, right here. 15t squared minus 5t minus 21t plus 7. Now, okay, 15t squared and 5t have a common factor of 5t. Pulling it out, we're left with 3t minus 1. Now, you have a minus 21t plus 7. Okay, we pull out a 7. We are left with negative 3t plus 1. But oops, these aren't quite the same. They're of opposite sign. So we pull out, next step, we pull out a -1. So a -7x times 3t minus 1, 5t times 3t minus 1. So now we have a common factor of 3t minus 1, which we remove, leaving behind 5t minus 7 here. So this factorizes that. (16y² minus 13y plus 2). All right. P and Q have to be -13. P times Q is -6 times 2 is 12. Okay, and after a very brief search, -1 and -12 work. Their product is 12, their sum is -13. So write -13y as -y minus 12y. Okay, 16y² minus y is y times 6y minus 1. -12y plus 2, pull out a 2, -6y plus 1. Oops, wrong sign, so pull out a negative. So -2 times 6 minus 1, y times 6y minus 1. Remove a common factor of 6y minus 1 times what's left, y minus 2. So that. And let me preview. This means that if we try and solve this equaling 0, it means this product must be 0, and therefore one of these two factors is 0. Now here we have two variables, 8m² plus 91mn plus 33n². All right, so the sum must be 91. The product must be 8 times 33, which is 264. After a fairly brief search, try 1, nope. Try 2, nope. 3, 88, and 91 works fine. Okay, so write 91mn as 3mn plus 88mn. There we go. These two terms, 8m² plus 3mn, have a common factor of m times 8m plus 3n. This 88mn plus 33n² is a common factor of 11n times 8m plus 3n. Remove the 8m plus 3n times m plus 11n, and that's the factorization.
Can you go back to 33?
Yes.
How do you go from the +2 to the -2 again?
Oh, here you see here.
Do you mind re-explaining it?
Here's the thing. 6y minus 1 and -6y plus 1. These are not quite the same. They're off by a sign. So I take another step by pulling in a negative. So instead of 2 times -6y plus 1, it's -2 times 6y minus 1. So basically this needed to flip all the signs, and I flip it.
Oh, okay. Yeah, I was just looking at it. I was like, how did you get -2 for it? But you were just
I mean, often
flipping the sign for it.
Exactly.
You don't have to do that though, right?
I mean, here's what it is. I could have gone from here to here directly, but that would be a kind of a jump of inspiration.
Okay, yeah, that's where I was confused. Because I think in my head I was just doing the 2 times the -6y times that.
Yeah. Oh yeah, I mean, sometimes you throw in I throw in this extra step just to make adjust the break.
Gotcha.
The idea being is that often it's tempting to just jump from me in teaching this. It's tempting to jump from here to here, but yeah, that would be confusing. Why a -2? Why not a +2? So here I naively pull out the +2, and then oops, -2, and then we're done. This is a general rule that you don't want to go. You don't want to try for goals. What you want is systems, a system for solving the thing. So that's what's happening here.
Okay, thank you.
No problem. All right, this one had a fairly longish search. 6t² minus 7t minus 20. Okay, the sum is -7. Their product is 6 times -20 is -120. Okay, well, so 1, -120, 1, -119, no. 2, -60, -58. 3, no. 4, no. 5, no. 6, no. Finally, 8, -15, and -7 works. So, and the problem being is that these were two numbers which had a big product, but they had to be of opposite sign because their product's negative, and their sum is small. So I had to go a fairly long way before I got a small enough sum. Anyhow, so -7t I'll write as 8t minus 15t right here. 6t squared plus 8t minus 15t minus 20. Now these two terms, 6t squared plus 8t, have a common factor of 2t. Pulling that out, this becomes 3t, this becomes a 4. Minus 5t minus 20 here, I'll just jump to pulling out a negative 5 and leaving a 3t plus 4. And okay, 3t plus 4 in common, there it is, times 2t minus 5, there that is. That's the factorization. And to repeat, that means that if we want to solve this quantity equals 0, then that means solving this quantity equals 0, and therefore one of these two is equal to 0. And those are easy to solve. We'll be doing that fairly soon, and early in chapter 7. Here's a cute one. 10u squared minus 13u minus 6. The sum must be negative 13. And the product is 10 times negative 6 is negative 60. So whatever p is, q is negative 60 over p, and we look for the sum of p and q. 1, negative 60, negative 59. Well, right sign, but too big. 2, negative 30, negative 28. Still not there. 3, negative 20, negative 17. Close. 4, negative 15, negative 11. Whoops, we skipped 13. And if we go on, these sums will just keep getting smaller and smaller, and we have skipped negative 13. So there's no answer. This is not factorable in integers. Therefore, this is what's called a prime polynomial. Now, it turns out this you can set this equal to 0, but you have to involve what are called irrational quantities. We will get to that later. Now here, there's a bit of a trickery in that there's extra factors of.
So for 73, you're just putting not factorable?
Prime, yeah, say not factorable, that's the answer. Prime is the answer, both's the answer, yes. So this is the answer. I always put a star next to the answer.
Okay, we're not going into deeper detail.
Well, I mean, not now. Later.
Not now. Okay.
Not now. We'll be, doing a. No, I mean it doesn't have a factorization in integers. Therefore, there's no rational solution to this. We do know irrational solutions to this, and we will get that later when we get to the quadratic formula.
Okay, yeah, that's the one I'm used to doing.
Quadratic formula, absolutely. All right, here's negative 6t to x to the 4th plus 15x cubed plus 9x squared. Now, okay, the 6, 15, and 9 have a factor of 3, and let's make it a negative 3 for fun. And there's x4, 3, and 2, so there's a common factor of x squared as well. So remove a factor of negative 3x squared, and then dividing these out by negative 3x squared, we have 2x squared minus 5x plus minus 3. That's a minus sign. Minus 3. 6, 3, 75. 6, 3, 6, 70, 75 minus 3. It's a little ambiguous here. I don't like ambiguity. Anyhow, so need two numbers, p and q, whose sum is negative 5. And its product is 2 times negative 3, which is a negative 6. And 1 negative 6 negative works fine. So whereas minus 5x is x minus 6x. 2x squared plus x, common factor of x, times 2x plus 1. 6x minus 3 is minus 3 times 2x plus 1. So pull out a 2x plus 1, leaving an x minus 3. And don't forget the minus 3x squared as well. When these factors come outside, please remember to bring them all the way down to the bottom to the answer, because I have people forget about something like that and lose the point. All right, so there's that. Okay, we're good. We're good to go for now. Let's stop the recording for now.